Alright guys, welcome to another quick video here. Make sure you just copy, get your stuff down as we talk about it. This should be a quick one. Alright, we are going to be writing on page 23. And we're just going to work on something called conversions. We'll get into more detail in it in Zoom, but you get your intro to conversions here, some good little notes. So our learning target is converting between logarithms and exponential functions. And so on this page, your first piece of notes to write down is this. All right, so what you can see here is we're introducing this new thing called a log to you. And this little number at the bottom, this little 2, is the base. And this is the log base 2 of 32. It's how you read it. Now, if you are going to turn this into an exponential equation, so I have this. This is a true statement. And the way I know that's true is that turns into 2 to the 5th power equals 32. Notice the number that it equals becomes the exponent on the base. So it becomes 2 to the 5th. And it will always equal that number in the middle. Alright, so we will use the term log. It is short for logarithm. So we usually just say log instead of the whole logarithm term. And it is the inverse of an exponential function. So logarithms represent inverse of exponential function. I just realized I had a typo here. This should be NC. There we go. All right. Now let's just do a look at a couple quick scenarios here. So if you saw 6 squared equals 36, if I asked you to turn that into a logarithm, that 6 becomes the base. The 2, the exponent, goes on the other side of the equal sign, and your 36 goes in the middle. So it's log base 6 of 36 equals 2. So similar piece, if you have 5 to the 3x equals 100, that 5 goes to the base, 100 goes next to it in the logarithm, and it will equal the exponent of 3x. And we can also go backwards. If you see log base 4 of 9x equals 7, that will turn into the base of 4 becomes the regular number, and the 7 goes on it as an exponent, and it'll equal 9x. So you just got to get used to the switcheroo of how we're going between these. That's going to be key for our next class. Now, how can we evaluate some very simple logs? So when I see this right here, I don't need a calculator. I can just figure this out just by looking at it. When I see log base 6 of 36, what I'm doing is I'm looking at this 6. And I go, what exponent on 6 gives me 36? And I go, oh, 6 squared. So this must equal 2. So similarly, I get down to this next one and I go, well, what number can I put on the 4? What exponent on the 4 gives me 64? And that's a cube. So that's 3. And the same thing, 2 to what power is going to get me 8? 2 times 2 times 2. So that's 2 of the, or 3 of those. So it's 2 cube. Oh my God, I miswrote that. Erase, Mr. Still stripping. It's just 3. The 2 cubed is 8. So that's how you can just real quickly evaluate these. You look at the base and you go, what could I put the base as an exponent that's going to make me equal that middle number? So we do these with some simple numbers like this. It's almost, the answer is almost always going to be something like 2 or 3. They're usually small because we're doing it in our head. All right, so with that, you're going to make sure you want to get into Zoom. You can't necessarily do all of this, this log maze without going to Zoom. This log maze is like the very last thing we did. It's just evaluating some simple pieces. What exponents will make you work, and you can use calculators to help you out. And then, of course, this is going to be on Zoom. You're going to need the zoom lesson to get these two. Alright, if you haven't done the quiz number 2, you want to make sure you jump in and take that. Alright guys, that's it for now. Take care, stay safe.